Okay, Hans, so you want to take over?
Yeah, sure. I don't need the screen just yet. I'm going to talk about a few things first. One thing is, I'm curious, the Chinese room is very self-consciously modeled on another idea called the Turing test. People may be familiar with that from the movie that came out just a couple years ago called The Imitation Game, but do people know what the Turing test is? Anybody?
Okay, let's see. Yeah.
It's if can I say it?
Yeah, go ahead, Khalil.
So it's like the computer should pass a test in order to be identified. Like it should fool people to think that another person is talking. So if I'm talking to like a word, like we mentioned at the beginning of the semester, it's like Pandora, who you can technically talk to online, and it formulates her own replies, and she can fool you into thinking that she's another person. So if you actually believe that there's another person on the other side, then it passed the test.
Okay, good. And in fact, there are several computers that can do this now. They had competitions, and one was at I believe at Bristol University in the UK, and it can be done now without much difficulty. And you may have had this experience yourself sometimes when you're like you're getting help on an online service for you go into it to get some chat, right? And they say, this isn't working right, and you're getting answers. And maybe sometimes you figure out that you're talking to a robot. And maybe you don't. Maybe you think, oh, that just was somebody getting paid minimum wage in North India. And so that's the idea. And one of the reasons why this was taken as a really important was a theory in psychology called behaviorism, which was the dominant school of thought from roughly the 1920s through maybe the mid 1960s when cognitive psychology started pushing pressure on it. But behaviorism, its most famous proponent was B.F. Skinner, was an American, and there was a British guy named Watson, who was the other one. And they basically said, look, in order for psychology to be scientific, right? Because psychology used to be the way that William James did it, and the way that arguably even Descartes did it, was to introspect, pay attention to what's going on in your mind. Phenomenology was this way. There is a lot of echo, I know.
Okay.
Okay, let's see if that helps. And what the behaviorist said was, you can't study beliefs, desires, emotions. You can't study those things scientifically. So let's not talk about them. The only thing that we can study meaningfully and observe is behavior and speech and those things. You can look at what happens to organisms, and you can look at how they respond, inputs and outputs. That's in psychology, that's called methodological behaviorism. We won't talk about what's going on inside the brain until we can do more. And so they said, let's just work on it. Now, in philosophy, as they tend to, this took an ontological or a metaphysical turn. And there was a view called philosophical behaviorism that said, okay, let's take that assumption to its logical conclusion. There are no beliefs, desires, and emotions. They're just ways of talking that we have. In the same way that we know what we say, but when we talk about the sun going around the earth, we do that all the time when we say, when is the sun going to come up tomorrow, right? You know what that means, but in fact, you're talking about a fake theory that we know to be false now. The sun's not going to come up. The sun's going to appear to come up, but it's all relative, right? That was the idea, that this belief, desire, and emotion talk, it was just sort of almost a superstitious way of talking about things. So the idea is, if you don't think knowing whether a thing has a mind or not has to do with going inside and probing it, the only reasonable question you can ask is, does it behave relevantly similarly? And before it was possible to make something into a robot, and speech is what we had, that was taken. So this really was taken to be a test. Is the machine understanding English? Is it understanding English in the way that, and then there's the next extent, is the way people do. Okay, so that's the first idea. Behaviorism, both methodological and logical or philosophical. Are there any questions about that before I move on? That makes sense? Vincent says, fine. Okay, well, yeah, okay, good. Now, the other notion that Searle is kind of assuming is this notion of intentionality, which is a frustratingly confusing notion because it sounds just like another term in psychology, where we talk about an intention as a plan, like I intend to go get a sandwich after this class, like having a desire to or a plan to. That's not what intentionality means in this context. They used to make a difference by spelling it with an S, intention, but intention in philosophy of mind and psychology is analogous to meaning in philosophy of mind and linguistics, where it isn't the structure, it's the meaning, the aboutness. The aboutness of an idea is what it represents in the world. So if you have a fond memory of last summer's vacation in Tahiti and with the way that the palm tree provided shade on a hot afternoon, that thought, that memory is about that beach on the other side of the planet. Okay. And that's what Searle's argument is all about. That's what he thinks machines, computers can't have, aboutness in that way. They can only operate on the non-meaningful or only the syntactic structures of language and code, as it were. So that's intentionality, and he thinks we can't have that. Was there a third notion I wanted to talk about before the structure? An example to sort of make it really intuitive what intentionality is and sort of its relationship to human thought. Hilary Putnam, and he did this in the 1950s, so everybody in the world would have known who this figure was. So the idea is some ants are moving around on a beach and they're pushing sand around. They're trying to do their thing. You know, they're moving some food stuff into the anthill. In the course of this, they're making some grooves in the sand. And someone walks along and sees all these shapes in the sand and says, "Would you look at that? Isn't that amazing? It's a perfect portrait of Winston Churchill." Okay, and when the person recognizes that and says, "Oh, look at that, it's a picture of Winston Churchill," all of a sudden that picture now represents Winston Churchill because of the person's thought. And the idea is, before that, when the ants were doing their thing, it didn't have any representational quality. It is that representational quality is imputed to the image by us, by our thoughts. Our thoughts can be about Winston Churchill, and by extension, we can give that picture derived intentionality. And that's a distinction that Searle uses. There's original intentionality, which is what you have. And then when you write something down, that thing you write has derived intentionality because you give it to it. And that's basically the main thing, the main tool he has to make this argument work. Okay, now I'm going to share some notes with you and we'll look through this a little bit. Okay. So the question Searle starts with in this article is, what is it to understand a language or to be able to think in a language? And there was a metaphor in can we understand the mind as a computer? You've probably heard this. The brain is the hardware, the mental states are the software. And what would it take for a computer to be able to understand the language it is using? This is just a little thing to describe what you just saw in the box, or the Turing test, where, and the way the Turing test is set up actually is you're talking to a real person and you're talking to a computer at the same time. And you're trying to figure out which one is the person. And this is, you don't need this information. I just want to show that this was what somebody was thinking about this 70 years ago. I believe in about 50 years time, it will be possible to program computers with a storage capacity of about 10 to the 9th to make them play the imitation game so well that the average interrogator will not have more than 70% chance of making the right identification after 5 minutes of questioning. I believe at the end of the century, the use of words and general educated opinion will have altered so much that one will be able to speak of machines thinking without expecting to be contradicted. You can think a little bit about whether you think that prediction is correct. Turing is the guy who basically thought up the conceptual framework for a digital computer. Von Neumann and Turing together sort of came up with it. Okay, Searle says, what's a computer? A typical computer rule will determine that when a machine is in a certain state, it has a certain symbol on its tape. This is going way back, 40 years ago. Then it will perform a certain operation, such as erasing a symbol or printing another symbol, and then enter another state. Okay, that's just a definition. This is the sort of tape they're talking about on these original ones, and they really were like this. You'll see them where the punch cards they put them in, but it's the same idea, ones and zeros, or if you work with logic, it's trues and falses. And that's the binary system that digital computing is based up from. And here is again sort of a functionalist, which is a development on behaviorism thing. There's you're paying attention. There's an injury, and then you say ouch, and you move away from the thing that hurt you, and there's other behaviors, and then you get inhibition. The computer model in a philosophical theory called functionalism is a version of functionalism that specifies inputs and outputs as symbols, that is bits of syntax. And it's functionalism plus what makes that box and arrow connections work is the way they are physical sentences inside the boxes. Okay, this distinction we've talked about before in this class, the distinction between syntax and semantics. Notice that rules specified in terms of syntax aren't about anything. Again, in terms of that new term of art, that means they don't have intentionality. The machine detects that there is a 0 or a 1 or a filled box or a closed circuit or whatever, but the symbols don't stand for anything. They make the machine running purely simply in virtue of their shape. So again, this is the Chinese room setup. Suppose you had a computer that was programmed to give answers in Chinese. If the computer is given a question in Chinese, it will match the questions against its memory and produce appropriate answers. If something does that, does it understand Chinese? Okay, that's all background. This is again what you saw the demonstration of in the short film Shadi showed you. And here's the guy that Turing imagined himself there. I'm just manipulating squiggles and squaggles to produce Chinese language behavior. I don't understand Chinese. The rulebook is in English. There's those instructions. Whoever or whatever is in that room is an intelligent Chinese speaker, says the fooled person. Okay, the computer has syntax but no semantics. Just another example, suppose you have a gadget that can multiply numbers. How does it do it? Start off with the assumption a equals 0. Is it 0? No. And then you can either go to the next loop or not. There's an adder, and the point Searle's getting at here is the computation doesn't go down any further than that. From the perspective of computation, there must be primitive processors, basic components of hardware. In the brain, these are neurons. In the computer, they are circuits. But Searle's point, no amount of primitive processing can add up to understanding or what he calls intentionality. No amount of primitive processing will give a system mental content, semantic contents. Okay, so that's the argument he sets up. He just basically says, look, when you look at these things that a system can do, it's analogous to, and here's kind of the move in the argument. He puts an intelligent understanding thing inside the system and says, we understand what would it be for that thing to understand Chinese, but we're stipulating that it doesn't understand Chinese. So if it can just do this, is the box an understanding of Chinese? He says, no. Here's some replies to that argument that he gives and goes through, which is really the main part of the article. The system's reply. So maybe Searle, the guy in the room, doesn't understand Chinese, but these AI developers who argue with him say, no, the room or the system as a whole understands Chinese. So, the guy in the room is just like a central processor. He's not the whole computer, we don't say. After all, your brain understands. We don't say that your brain understands, we say that you understand, right? Searle's answer, why did it make a difference? Just let the person in the room internalize all the elements of the system. It still wouldn't help. Basically, the bits of paper and the instructions go in. There's no place where you want to say, oh, there's understanding. Okay, so that's the first back and forth. Someone says, no, it's not supposed to be just the processor, it's supposed to be the whole system. Searle says, nah, that's not gonna work. Second reply, the robot reply. What if we put the room inside the head of a robot and could go around the world and perceive, etc.? Searle's answer, if that works, first of all, it takes for granted that cognition is more than just symbol manipulation because you have to go around. He says, on the other hand, why should it work? What about putting it in the robot makes it seem like there's understanding? What the robot, the system, and the room all lack is what you have. That lets you understand language, awareness, consciousness. The problem of understanding is that's related to the problem of consciousness, Searle says. How do you know what words mean? How do you know what screen or Hans refers to? He says you've encountered these things, that you've met them, you've interacted with them in a way that the machine can't. Third reply, the brain simulator reply. What if we designed a program that simulates the actual sequence of neuron firings at the synapses in the brain of a native Chinese speaker when she understands the stories in Chinese and answers them and gives answers to them? So it gives two responses to this. The first is that imitating the operations of the brain doesn't help. To see why this is so, imagine that instead of a monolingual man in a room shuffling symbols, we have the man operate an elaborate set of water pipes with valves connecting them. So it's a very, very big simulator. So it must be massive. It passes the Turing test and it mimics the brain. Now, where's the understanding, he asks, in that system? Okay, that's the first one. Think about whether or not you agree with that. First is the first thing. And here's the second response. The problem with the brain simulator is that it is simulating the wrong things about the brain. As long as it simulates only the formal structure of a sequence of neuron firings at the synapses, it won't have simulated what matters about the brain, its ability to produce intentional states. Okay, and then the fourth reply here is the combination reply. We put the system in a robot, which includes a brain simulation, and it walks around interacting with the world. And here's Searle's, I think, surprising response. If we would build a robot, if we could build a robot whose behavior was indistinguishable over a large range from human behavior, we would attribute intentionality to. We'd say, yeah, that guy believes and he thinks and he has memories, but we would be mistaken to do so. He says, my own view is that only a machine could think, and indeed only very special kinds of machines, namely brains and machines that have the same causal powers as brains, can think. So there's several things going on in this article. He takes it as, well, okay, instead of me giving a summary, let's just sort of try to open this up for a little consideration. It's interesting. This was written in 1980, so it's a full 40 years ago, and he hadn't encountered nearly the complexity of artificial intelligence we had, but people had just started using the phrase artificial intelligence. And he's trying to come up with basically an a priori argument that is not an empirical one, but one where he's just sort of thinking through an argument based on principle that non-human computators, non-human computers, non-human cognizers can't have meaningful thoughts because of the way that they're built up from a binary logical system, because they're digital, zeros and ones. Is Searle's article argument convincing to you guys? That's my question. Or do you want to raise questions about it? And please, I know I went through that fast because I was thinking you guys had read it. But so if there's any just questions about the article, I'm happy to answer those too. But I'm also interested in hearing whether you found it convincing. We have one person who says, I agree with Cyril. That's Sana. Seriously says he addressed the objections. Daniel says it's convincing into the last two slides. Okay, Khalil and Sana, what is convincing? And if you wouldn't mind speaking so we can hear you, why is it convincing?
So I found it very convincing, and it's like he was calling, it was like a call for action to change the path on which AI is now, maybe it already changed, but on which it was going. So instead of focusing on trying to duplicate human intentionality and trying to come up with like conscious AI, instead they should paths and see different ways to develop AI and try to get different things out of AI, not just that specific target, because he kind of made a convincing argument that coming up with consciousness for AI is kind of impossible because it's all based on the biochemistry that's able to bring that about. He says it could be possible that other forms of consciousness are out there, but the ones we know and the ones we like think of is solely the like emergent property of the specific biochemistry of like us. So yeah.
Okay, so do people,
Professor?
yeah.
Yeah, I'd just like to say something. I guess I didn't really understand why is he saying this. All right, yeah, we know he's comparing these machines that we now know of that they cannot understand, and like I think everyone knows that, right? Like for now at least, they cannot understand what they are doing, but I fail to see how this is crucial in a way. I mean, even if they do not gain consciousness, they're still helping us in some way. Even if they get super smart, they don't have to necessarily understand. But I don't know if you can see my point.
No, I do. So what? Right. He's and you're putting your finger on an important issue, right? He's claiming he's making a in principle or a priori argument, and this is what I think Khalil identified. What he's done is he's pointing to an empirical fact, which is the only understanding things, for lack of a better word, the only things that have intentionality that we've encountered are other human brains. That's an empirical fact. And then he says, well, there's nothing else that has that power. And it's not entirely clear why that empirical fact is important, given that he's giving an in principle argument saying nothing that is based on a binary or a digital system can be conscious, can be aware, can have intentionality. So that does seem relevant. His pointing to the fact that actual human brains do have intentionality should be irrelevant to the in-principled argument, right? So that I think is I don't quite know who was speaking there, but who just
was me, Jad.
me. Yeah, Jad. I think that's an important point. Sana wants to add something to what Khalil was saying.
And also Daniel, I think, had something to say, I believe.
Yes, I read about Sahel and everything Khalil said, like I wanted to agree with as well, because he was actually defining the whole thing. He was trying to make us understand that, okay, so to speak, like machines we're all machines, like in a like common sense, and in a way that like, okay, there's a set of functions that we are supposed to do and we do, then we are all machines. But the idea of intentionality, he says that it's only a human possessed because of the whole like biochemical processes, and a digital computer has no causal powers which are like linked to the whole thing. And states that simulation is not duplication. So that's basically where I'm at, and I really do agree with him on this.
Now, when you say a computational system has no causal powers, I mean, you've been in an airplane, right? And when that airplane gets close to another airplane, it keeps those airplanes from crashing. So that's a causal power, right? Some of us are alive because of that causal power. So in what sense do you mean that these digital systems don't have causal powers?
In the sense that like in the way Searle defines intentionality, like as a causal power of the brain uniquely produced by biochemical processes.
Okay, I would challenge the idea that that's a definition, really, but yeah, that's what he does say. He says what intentionality is something that our brains produce. Okay, that's a point. He says that other species have various levels of intentionality. So, okay.
Can I add something on this? So I don't know if so. I was discussing this with Hans before. So I mean, when it comes to biochemical,
Can we hear from Daniel first?
Yeah, sure, yeah.
We've been making him wait a while. Daniel, did you want to?
Go ahead.
Yes, so what I wanted to, so I was going to make, I was going to refer to a movie, I think, like it's a theoretical thing, and that was where I stopped agreeing with Searle, the philosopher, I think. So the movie is Chappie, and I think it's theoretical. I don't know if it's something that is actually real right now, but basically the idea for the intelligence is such that there was just but like the systems have been created sort of like a neural system in the brain, and he argued against that, but I don't think it actually exists to say right now to say if it works or not in context of what he argued about. So it was like, okay, just create a lot of all this, created such like you're creating a human brain, and then let's it interact with the way, say, a child would interact with the environment, and then see how it learns and see how it learns, not learning from data that maybe you just feed it or things like that, but let it interact with the environment, people walking around. I mean, the operating system was obviously installed in a robot. So the movie is called Chappie. So at that point I thought, okay, maybe that kind of approach to in intelligence system might be what might replicate human intelligence, I think.
So your thought is if we could have one of these Chinese room machines inside a little miniature robot and we raised it with us, and every once in a while we could make it bigger, it learned language the way we learn language.
Yeah, maybe even faster.
Yeah, that's an interesting suggestion, definitely. Shadi, what did you want to add?
I wanted to add two things, right? So one on what Daniel said right now, but first this biochemical argument, right? I mean, if you think about it, an airplane, I mean, it's capable of flying, and I mean, it's not the way a bird flies. Yeah, so a bird flies through a completely and totally biological process, and an airplane is super mechanical. But you can't argue, right, that an airplane flies. I mean, flies from place A to place B. There is no question about this. And so I feel, right, that this idea of having, something that is that only understanding and thinking is a biochemical process is a little bit narrow in the sense that you're saying, okay, since it's biochemical, we cannot, simulate it or create it using other mechanism or other medium. So that's just one point that I wanted to make. The second is about what Daniel is saying. I think there's a lot of research now on doing this, really. So just letting programs learn from experience. So reinforcement learning, right? Like these robots that learn how to walk and navigate things. They really don't teach them anything. They just let them in the wild, and they have a reward function, and they kind of start learning how to walk or how to interact with the environment. around them and so on. So I think, right, I mean, this also capability of learning. So this idea of the Chinese room, I think it's a great argument and everything, but one thing that I have against it is that, in fact, right now you could actually teach, a model to learn Chinese or to speak Chinese by just exposing it to, different questions and answers, and it could actually learn to figure out what are the rules of the language and so on. So I don't know if these things, you guys thought about as well, or you agree with or not, right? This is just 2 points I wanted to make.
Can I add something?
Sure.
About what you just said, I don't think it's about like if they are able to maybe like do those certain functions like alone individually or whatever. I'm just saying that in your own personal opinion, do you think that they can think the exact same way we think?
No, they don't think the same way we think, but I cannot claim or say that they also don't think, right?
No, I mean personally for you guys that in the future with all the advancements that happen, like what are your opinions on it?
My opinion is that it's different way of thinking, right? But I can't rule out that it's not thinking, right? So really, the same way like airplane flies differently from a bird, right? From an eagle. It's different ways of flying, but both of them achieve the same goal, which is flying. That's really the point I was trying to make.
Yeah,
But,
and I think, I wanted to also add that. So it's also the same way, especially the reinforcement learning that Dr. Shady talked about. Is I think it's the same way if you take a newborn baby, and you take. It doesn't matter. So I'm just going to paint a scenario. You can take a child that was born in Nigeria and take the child the moment he was born to the US. It doesn't mean that because he was born in Nigeria, he's going to just naturally get things and behave like Nigerians or have cultures like Nigerians. It's like if you take that child and put him in its different place, it's going to learn things about that place. So it's the same way I think the same way if you sort of like take a machine, a model, a network a model that has been built properly, and you put it in a place to just learn and just look at things and just pick it up and just listen and learn. It's going to just probably very likely, learn and actually think like we do.
Yeah. And there are very sad cases of children who, for various reasons, have been not in social contact during those formative years, but I think between 2 and 7. One was where the child was really cruelly kept out in the backyard with dogs and was fed like them. And its socialization came from those other mammals, not from people. And that brain didn't get, I'm going to go all metaphorical now, that brain didn't get the programming it needed to pick up language. And that person never will learn language because it's too late. And this is one way to think about it. I mean, I want to go back to that notion of intentionality that I started with, and I know lots of you have comments and I want to hear it, but I just want to ask you one question. So now I made that point about the picture in the sand and the guy making the example in the early 50s when everyone on the planet knew who Winston Churchill was because he gave these famous speeches in the war against Hitler, blah, blah, blah. If my 10-year-old daughter, oh, she's going to kill me. She's 11. If my 11-year-old daughter came across that drawing in the sand, she might recognize it as a face, but she wouldn't know it's Winston Churchill. So what's the key difference there? For Sidney Putnam in the example, that person thereby bestows the meaning Winston Churchill on the picture. When my daughter comes across it, the meaning Winston Churchill doesn't get bestowed on it. So in some sense, there's a level of meaning in one of the organisms and not the other, and they're biochemically the same. Their brains have the same causal powers, but something else is going on there that makes the intentionality more or 2-leveled instead of 1-leveled. So I don't know if this is not a question I'm expecting an answer to, but I want you to think about that. There's something there that's important about the difference between meaning A and meaning B. Now, there's lots of comments going on. It's, somebody mentioned the movie This is like the other articles in
No.
which
Khalil wanted to say something, and then
Yes.
right. So go ahead, Khalil, and then we'll read the rest of the comments. Yeah, go ahead.
Thank you. I just wanted to reply to your comment about the bird and the airplane. I thought that like what Sarah was saying wasn't narrow in the sense of thinking that only humans can have this type of thinking and it's not reproducible. I thought like it wasn't narrow as you were saying. I thought it was just in a different way that, for example, for the bird, we were able to recreate the way the bird uses lift and the laws of physics in order to just fly, you know? So it's all grounded in physics. And I think he mentions that it's the same thing for the brain and for our own like this emergent property of thinking. So unless we go ahead and reproduce it in this chemical way, that which is harder than a physical way because it's more compact and etc. Then unless we do that, it's much more difficult to recreate thinking the way we know it. So he's not denying the possibility of other ways of thinking, other conscious types, other like intellects. But he's just saying that like it's a dead end if you're trying to recreate the same property in a different way.
Yeah, I see what you're saying, but I disagree with you. I mean, the airplane doesn't fly the same way, you know, a bird flies. It's just it's a purely mechanical process. Yes, it uses laws of physics, and it maybe, you know, it imitates the idea of a wing or something like this. But it really, I mean, if you look at it, it's a machine, right? It's all mechanics. You have a motor, and it goes at a certain speed, and that's what, you know, makes it, you know, beats gravity. So it's not really exactly, I mean, if you open a bird, right, this is not how a bird flies, right? It doesn't have a motor that makes it, you know, when it goes really fast, it starts flying, right? So it's inspired by a bird, but it's not really, I mean, the way a bird flies. And that's what I was trying to say, that, you know, we could achieve thinking not necessarily the same way a human achieves thinking. That's what was my point, right? Or my argument against this last bit, you know, which is this biochemical, you know, idea or argument. Okay, I think what is Nell? That somebody said Meher, right? He said there is a Nell movie or something like this.
Yeah, that was a reference for what Dr. Muir was talking about with the child. So Nell is actually a true story. So she was left in the woods for a long period of time, and she grew up with nothing. And then the movie explains actually how she interacts with the world, and, you know, the various levels of consciousness that she can actually present towards the world around her, and what is that. So the similarity, there is kind of that reference for what learning happens to a child versus what learning happens to a machine. But there's a point that Theo mentions in his argument, and there's the distinction between the mind and the brain in terms of one does the actual function of, let's say, drawing up conclusions or making the connection points, and the other is actually related to actual understanding of the object there. And that, I think, it really adheres to the narrow artificial intelligence, the kind of a very strict artificial intelligence. And I've worked with chatbots since 2017, for example, and I've seen them evolve in that sense, from having them directly linked to a certain database, and the other when they would actually find an answer to there. But when we go towards general artificial intelligence, and I believe that area is where Cyril's arguments will not hold in that form, because we're not teaching the computer everything, we're teaching the computer some of the things, and the computer is able to abstract into another layer, into thinking about another object. And for that to think of is very tough, because we haven't really seen general artificial intelligence. And from this perspective, there's a movie called Ex Machina. I don't know if you've seen it. Ex Machina, there's a computer software developer that wins in a company and gets to spend 2 weeks on a private island with the founder of that software company. And there he actually speaks to this robot that was developed by that founder. And over the course of 2 weeks, there are interactions that comes in place. And their intentionality is actually present because that robot wants their freedom and is trying to devise ways to get out and manipulate and stuff related to that. So that brings the closeness to general artificial intelligence into play.
Okay, sounds good. Thank you, Meher. And Georgie, so I think Georgie also brings a good point that was talked about in maybe the other articles as well, which is this ability of explaining the thought process. So I don't know if you have any comment on this, or Hans, if you have any comment on this idea of, explaining basically.
Yeah, I mean, we also can't describe our own thought processes.
Yes.
None of us can access again, let's just speak metaphorically. None of us can access the programs that are generating the streams of sounds that are coming out of our mouths or that we're typing into the chat. That's just a part of our processing that's not accessible to our conscious awareness. We wouldn't say that it's not real or not there or not meaningful because of that. And another way coming at that same kind of concern is we're talking about these special causal powers that the brain might have or that Searle thinks might have. What's special about intentionality in terms of our brain's ability to produce it, right? So can an elephant feel pain?
Yes.
Okay. But it has a very different brain than we do. It doesn't, its brain doesn't have the same causal powers that ours does. Mm-hmm. So we need to be really careful about, and I'm stealing an argument here from the animal rights movement. We need to be careful about being chauvinists toward our own neurological structures and saying this is the only one that is quote unquote meaningful. So that's sort of a big and abstract idea, but I would like you to think about that. And in the past, it's been very easy for people to look at other kinds of people and say, well, they're different enough from us that they don't have, well, they're not human.
Yeah.
So I think we have a, I'm not don't want to make a war about discriminating against robots, but we have enough obligation to default towards behavior in terms of whether or not something counts as intelligent.
Yeah. I think that brings us to, so I wanted to do another exercise. I know, Meher, you want to say something, but maybe, let me do this one last exercise that I think is quite related to this last point in particular, and also to the whole discussion, and then we'll hear from you, yeah? So hold this thought for a second, Meher. So can you see my screen now?
Yes. Okay,
great. So I want to take you to just a small demonstration of one simple system, an AI system developed by some German university. And what it does, this is called visual question answering. So you show it some images, like this, a dog or something like this. So we have here a sample of set of images, and you can ask it any question about this image, and it will try to answer your question. And I tried it for a few things, and it's really interesting that it gets the answers correct most of the time, but it also shows you how actually it's coming to this answer. So where does the neural network focus in the image to be able to answer your question? So it tries to understand the question. So it will show you where in the question it's focusing and where in the image it's focusing to answer the question. I thought that's a great demo to show you the way these algorithms or models think. Right? And I put think between quotes, of course. Right? So let's try this out. Yeah, I can ask it how many elephants are there. Can you see? You can see my screen, right?
Yeah. Yes.
Okay. And it gives you, the AI delivers the answer in a few seconds, and it gives you the 61%. So it does, a probability of different things. First of all, it figured out that that's a question where I have to count, and it gave you 2, and it shows you, right? So the most important word that it focused on in the question were, elephants, and then are there. So the more red the word is, the more important it is. and figuring out what is the question about. And that's in the image where it looks, so the white areas are really things that are relevant, and the areas that it's focusing in are the ones shown. So it looked at really the elephants and was able to determine the right tool. I could ask it another question, so I could ask it, what color is the tree, for instance, and it gives me green. And you look at it, where is it focusing? It's focusing on the trees. Yeah. Let's try another example. For instance,
Can we ask a question?
Yeah, sure. You can ask any question. Yeah.
Can we ask is there a third elephant hiding behind those two?
That's a difficult one, I think. But let's see. Third elephant hiding behind these two, right?
Yeah.
Okay. The answer is no.
Wow. Okay.
Right.
Maybe.
Okay.
No,
Yeah.
no.
We can try another image, maybe. Let's try, I don't know, maybe this one. Let's see. What is chicken? I know it's not a chicken, it's a rooster, but let's see. Is it eating a cake or something like that? It's eating fish, right? So got it as fish. I don't know if that's a fish. That looks like a cake to me, right?
Yeah, if it's fish, it's messy.
That's really disturbing if it's a fish. Yeah.
I guess it's cake, partially pizza.
Yeah. Is the glass, for instance, full or empty? Let's see. I mean, so it's just a demonstration, right? Of really, so it gives you that it's actually empty with 62%, and it truly focuses on the glass. Yeah. So you can try this. I have the link for this. You can play with it. It's quite interesting. There's a lot of other, by other universities and other software companies that have similar demonstrations. The task is called visual question answering. And this is just purely trained using a neural network. So you just show it a lot of images with a lot of words, and it learns how to connect words to pixels in the images. Yeah. So when I asked this, is the glass full or empty? It really looked at focused on that. It figured out that glass is the place where it should focus in the image. On and really then deduce the answer to the question. Of course, it knows if it's a question that starts with an id, then it's a yes or no. So really, it does a few things like that. Yeah. All right. I want to end this the exercise by a small poll that I created, and then we can continue with the chats, just to see if you have, after this demonstration, you still think, right? How do I do that here? 1 second. Top share.
Fish cake.
Huh?
Somebody put fish cake, like a crab cake.
Fish cake, yeah, could be, right? So I don't know how to do a poll from here, because I'm on my iPad, so. Okay, I'll do it from the laptop, right? So I'll connect from the laptop and launch it. But for now, you can. So Maher, you wanted to say something, and if you have any other comments after you've seen this, small demonstration, also please chip in.
Yeah, sure. I actually wanted to ask Dr. Muller to elaborate more on the mind versus brain distinction that Cyril talked about, and ask about consciousness, if in philosophy of mind that relates to some metaphysical matter or not.
Well, that's a whole matter for debate. Some people think that the distinction between mind and brain is a distinction without a difference, that the brain just is the mind. Some people think there could be no big difference in the world. Going back all the way back to the 17th century, there's been arguments for that. Functionalism, which is sort of the dominant theory of mind behind cognitive science, says that it makes a distinction between the architecture and the level of description that you're working with. So they're just like when you look in our brains, you're not going to find the belief that there's two donuts on top of the fridge, and so when you go home, you'll reach up and grab. There's no brain event that coordinates to that, but we do think that the brain is what generates that behavior. And so the functionalists say that you could have a number of different architectures that could run that information, right? They say, so they're against the Searle's idea that it's just what people say is wetware, right? If the metaphor is hardware, software, Searle seems to dig down and say, no, it's only wetware. It's only squishy neurological stuff that can do this. So, I mean, the relationship between mind and brain is a long and complicated kind of set of issues. Consciousness, yeah, consciousness is when people were asking about qualia, and I said people should take a look at Frank Jackson's article and my response to it. That's one way people have tried to talk about it, right? Some people say there's no way that a computational system could have feels. That like it might, the system might be smart enough to say, oh, if you go too close to that fire, it'll damage the system, but it won't go ouch and feel the pain. Some people challenge that and say, no, if it's complicated enough, that's a really very efficient way to process information to turn it into pain. So why wouldn't it? So my quote unquote elaborations on the things you asked me to elaborate are just to say that there's a lot of dispute over all those terms, what consciousness is, whether people are uniquely conscious or whether there's other things that could be conscious in theory or principle, and mind and brain. I don't remember where Searle does it, but he's definitely one of these people who thinks that minds are different in kind and not just in type from biological stuff. Searle gets into some trouble with that. Some of his stuff is so resistant to talking in terms of mechanisms that he has trouble explaining that the function of a heart is to pump blood, because that seems kind of meaningful, right? Right, because a heart isn't just a muscle. It's a muscle that has this particular functional property that it needs to move oxygen around the body. And Searle's ontology is such that it's not, that looks a little too meaningful and thoughtful for his system to be able to account for. So I think his metaphysics is kind of mistaken, but that comes from other parts of his writing. I don't know if that makes sense. The question between
Okay, so meanwhile, I launched the poll, right? So if you would like to participate, that would be great. Yeah.
After going through some of the examples from the video,
so majority says no, right? So we don't think it understands the images and the questions. Who said yes? Anybody? I see there are a few who said yes. Can you tell us why do you think they did? And then we hear from somebody who says no.
21. What is 21%? 2 or 3 people?
So let me see. So I have how many? I have 5 out of 21. So it's percentage-wise. It's 21% that said no, and the rest said yes. Sorry, the opposite. 21% said yes, and the rest said no.
Yes. I was just curious. Yeah. The reason I asked was because I said yes. I was just wondering how many students did, if that was.
Yeah, so that would be just remove 1, right? So 5. So it's 4 out of 20. That would be 25%. Yeah, 25%.
So I saw Daniel said yes. You're brave, Daniel. Tell us why you think the program understands the images.
So because we got more correct answers than wrong answers. That was it. Because the only thing we got wrong was the fish and the cake thing.
And we didn't know what it was, so it's just as smart as us, right?
Yeah, but I think it clearly wasn't a fish. I mean, apparently it wasn't a fish, and we're not sure if it's a cake, but it's still sort of like got it right. It's possible. So if we take the thought process of, oh, maybe this AI is a baby, right? It's possible the baby is gonna call it fish.
Exactly.
Something.
Yeah.
Right?
I like your answer.
Like, yeah. So it's possible. I'm still learning, but I try to get it right. We don't know everything, but if I get more stuff right, it means maybe I'm a little bit smarter and more experienced. Yes, that's what I think.
But so for me, right? I mean, it's obviously you know my opinion now, right? That I'm more inclined to say yes, and for me, it's actually it went to the plate, right? I figured out that eating is has to be in the plate, and that's where it went, and looked, and then maybe just if you ask a child, it might also say something really strange, right? So as Daniel said, right, could be that if you teach it more, it will actually be able to use that. That's obviously not fish, right? Because birds cannot eat fish, for instance.
So
right?
Gloria makes an interesting comment. Gloria says, I think that it compares the given picture with data it already has. I don't know whether you mean that to count against understanding or towards understanding. Which do you mean, Gloria? Do you think the fact that it compares the picture with data it already has counts in favor of it being understanding or against?
Can you repeat your question?
Okay, you made a comment. You say, I think it compares the given picture with data it already has. I can imagine one saying, well, it's just comparing data it already has, so it's not thinking, or saying, wait a minute, that's precisely what I do, so it is thinking. I was just curious what you meant when you said, I think it compares the given picture with the data it already has. Does my question make sense? Or?
Yes. For example, I asked a question. I used the model and tried that. I asked how many flowers is there in the picture. It said 0, but there was a lot of pictures because it was not so clear. The picture was not so clear. So so when you give it the picture, you compare it with all data.
Yeah. So we didn't hear you very well, Gloria, but I assume that you tried it and it didn't answer correctly for one question. And yes, it definitely uses previous data to be able to deduce things, right? But that's this could be also seen as how we do learning. I mean, we learn by examples, right? That's really how humans do it, right? We try to look at examples, and that teaches some concepts. And I think that. Yeah, but are you so you're against, right? You think it doesn't understand, right? That's what your final verdict, right, Gloria? Because the sound is breaking a little bit, breaking up a little. Okay. So who does, like other people who said no, it doesn't understand? Anybody can, one last statement? Why do you think it doesn't understand? So from the people, the majority that said no.
The great silent majority should become less silent.
I can give a shot for it.
Yeah, sure, go ahead.
So this is also related to how and what do we define by understanding? If we speak, if Sorton speaks as that. So the idea comes behind in terms that, is the computer really able to, other than identify or classify the information as there, does classification here in that sense offer that kind of understanding? So this is where my question comes into play.
Mm-hmm. But there's no classification here. It's really answering a question, and I've shown you what it does, right? Its way of answering this question is to really start figuring out in the image where to look, right? And then from that, figures out the answer. So why?
But I would say that even while answering a question about a particular image, so that image has been analyzed and that image has been classified into various fonts. So if I take that question and I put it in terms of a chatbot kind of scenario, I'm really looking at the intent of the question there. So the intent of the question is to figure out if a particular classification, if it exists in its analysis of the image or not. So renderly speaking, I would say that this is a classifier.
It's not exactly a classifier. It's it's a question answering system. A classifier says, take an image, and classify it into a certain set of categories or classes, right? So I don't agree with you that this is a classification task. It's a much, broad task, right? It's a question answering, but you're looking at an image and, right, you're trying to use it. So it's not per se classification. But
it's the same with chatbots, right? So if I train a chatbot on a particular database, let's say about this course, so I get all the information from you and Dr. Muller, and I have this database of information for it, and I have this chatbot which answers questions. So it's the same, no?
Yeah, but again, a chatbot is not a classification, right? So it and one part of its processes might be classification of the intention of the question, to know if it's a question that I should answer with a yes or no, or I should answer with something like this. But it also does generate text. There's a lot of generative models there. There's certain things. So it's not a classification task, and that's it, right? That's just one comment on this. Yeah. But,
that's clear. Thank you for making that point. So my point goes on back in terms of, does chatbots actually make the understanding or not?
Yeah, I mean, I think it's a difficult question to answer, right? I think that's the whole point of the whole session. Is really, I mean, to me, it's a question that is difficult to answer. But
there's no easy yes or no answer here.
Yeah.
Otherwise, we would have spent 5 minutes on this instead of 95.
Yeah, exactly. All right, I think we're out of time, but thank you, everyone. Thanks, guys. It's always interesting. And yeah, we have almost two more topics to go, and that's it. Okay, talk to you next week.
Okay, that's just the
right. Okie dokie.
So what's up for next week?
Let's see. So I fixed the things that we discussed, right? So if we go back here, so I removed the second part of this this module. Let me share screen so it's easier for you to see.
So we've got 4 readings.
Yeah, and I looked at them. I think this Chinese one really not relevant or interesting. So this one, Beijing wants AI to be made in China. I mean, it just sounds right that they're really spending a lot of funding and putting a lot of money, and they want to really.
Yeah, that's more important, more interest to jingoistic Americans who want China to stay, but not number 1. That's,
Yeah, exactly. Really, yeah, that's pretty much it. So I thought we could remove this for sure, right? Hello?
yeah.
Okay. And we have the, I think the first one is a video. It seems interesting. It's around half an hour, right? So 30 minutes.
Okay.
It's talking about, yeah, the implications of AI and on jobs and on the economy and so on. So I think it's quite relevant. Yeah, the second and the third. So the third one is talking about, how, self-driving trucks are gonna put a lot of people out of jobs and so on. And yeah. And the second is a paper, I think, that goes through some case studies.
Ironies of automation law.
No, sorry.
The ironies of automation law. That one.
Yeah.
Good.
So I think these are the 3 are quite relevant, and I think the first and the third are really easy and short. So I think we could keep those 3 and remove the Chinese one. Yeah.
Yeah.
Okay, I'll do that.
So I'm up
for reflections. Yeah. Hello?
Yeah.
Okay. So yeah. So I think and Mark is the one who's correcting the summaries. Correct, Mark?
Yeah.
Okay. Sounds
For
good.
next week.
Yeah. Okay. All right.
I have a very funny example that fish cake thing brought to mind.
Yeah.
Bana shared it a while ago. Somebody on some, it was a tweet thing, shared it. She was like, "What the heck is a crab cake?" And this guy says, "It's a cake with crab." Duh. and this woman, she goes off and she's like, "English isn't my first language, and I hate it when everyone on this thing who's American just assumes the whole rest of the world has all your reference points." She's like, "Cake is supposed to be sweet. That's supposed to have some kind of salty seafood."
Really, yeah.
I can't remember if there's any cursing in it, but otherwise we should share it with the class.
Yeah, we should. If you can find it, yeah, definitely send it to them.
All right.
Okay.
Good class, I think.
Yeah, it went really well. So we talk then on our Mondays off. Do you guys want to still talk, or you want to talk on?
Oh, that's right. It's Independence Day.
Yeah.
That messes up my logic class. I think we have 50 sessions.
Yeah, the same for us, right? We're really running out of time. We just have like 4 more lectures or something. But non courses.
Yeah, I don't see any particular reason. Well, it's often good to chat a little bit after we read them, just so we have a plan.
Yeah.
You want to talk sometime on Tuesday instead?
That's fine with me. Tuesday, I'm very flexible Tuesday. I think I have so speaking of Tuesday, right, this Mariette Awad, right, from ECE, Computer Engineering, right? She's teaching a class in machine learning, and she wants to do a session on ethics, particularly bias. And she asked me, and you, if we're interested in, joining her in this session. So I don't know if you're interested or not, or if you're free or not.
Did you get an email about that? I don't remember that.
No, she talked to me, and I told her I'll ask Hans, right? And I honestly never did, right? Like it slipped my mind until now. She's calling me. That's why I remembered, right? Like I told her the phone ringing, right? So she told me by phone mostly, right? Like that she wants to do that, and I tell her I'll ask Hans. Yeah.
Well, as always, my main question is, what does she want from us? Does she just want us there as discussants, or do we have to present something?
Yeah. So I think we could, she wants to focus on bias. So I told her we could run some of the demos we've run, right, on bias, and then just discuss with the students if they want, right? Like I don't plan on doing any presentations or anything, right? So yeah. I think should yeah. I told her we could talk about this Google image search, what we've done, this word embeddings bias, right? We could show them some examples of this and then talk to them. I don't know if that's even interesting to you, right?
No, sure. Listen. Are you inclined to do it?
I am, right, because I think it's a good publicity for the class as well, right? So that's honestly to just spread the word that we're doing this and
anything that we can do to increase the likelihood that we can co-teach it again and get full credit.
Exactly, right. So really, that was the only.
When is her session? It's on Tuesday.
It's Tuesday, I think at 2. Yeah, so I'll confirm with her and then send you an email. Yeah.
Yeah, especially if we can just. Will they have read something on bias?
I sent her, the keynote talk, right? Remember? So I asked her to kind of.
That New Zealand woman, right?
Yeah.
Okay, yeah. I'll just look at my notes from that. That'd be fine.
Yeah. Okay, and the one with campus and how they analyzed campus or something like this. Yeah.
Sorry, and which person is this? I'm trying to think if this is somebody.
Marietta Awad, right? So it's from computer engineering. She's I don't know if you know her, Marietta Awad.
I think she came and met with me when they were talking about this. When that GE was working on an ethics of technology course.
Okay, could be, yeah.
She's kind of young, right?
Relatively, I mean, she's our age, like not young, not old, right? Like. Yeah. I'll send you her email, her website.
Okay.
Hang on a second.
I'm so bad with names.
Yeah, me too in general, right?
It's kind of a shame because there's probably only 4 or 5 women in that whole faculty. We should.
True. Yeah. That's fair.
But okay, so if we do that, then just maybe we could even just 15 minutes before have a quick conversation.
Sounds good. Yes. Yeah, we could do that. Yeah.
What will then be tomorrow? About Wednesday.
Yeah. I think so. Yeah.
Cheers.
Okay. I'll send you the link to the Zoom thing, and we could just get in and just discuss with I'll show them the couple of examples that we've done, and we take it from there, right? Nothing really too much, and hopefully, as I said, I think it's a good publicity for the course in general and the area, right? So it shouldn't be too bad. Yeah.
It sounds good.
Okay. Awesome. Okay, guys.
So who's doing the? Did we talk about
the summaries?
Yeah, you already told us that. I'm repeating.
And Sarah, you finished correcting the summaries for this week?
Not yet, just a little bit more.
Okay, so yeah, let's try to finish it this week, yeah? So
yeah, of course.
Okay, perfect. All right. Talk later.
Thank you. Bye-bye.
Thank you.
Bye, everyone. Bye.